Today we're looking at topic 10-3. We're going to be learning about the fundamental counting theory of probability. The fundamental counting principle is a way to calculate all the possible outcomes in a sample space with two or more events instead of having to create a tree or list diagram. In other words, I'm looking for ways to help save you time. So the probability principle, it looks at the probability of getting, in this case, we have a number cube. We want to look at the probability of getting a 3 with one throw. Well, there is 1 3 on the cube, and there are 6 total numbers. So the probability of getting a 3 on one throw is 1/6. Well, the probability of getting a 3 with a double throw, this is throw number 1, and this is throw number 2. So the probability on the first throw is 1/6. Then the probability on the second throw is still 1/6. If we multiply those two together, then we get 1 in 36. So the probability of getting a 3 with a double throw is 1/36. If you wanted to create a tree diagram to verify that this is correct, do so now. So we're looking at this outfit selection, and we have shirts, shorts, and shoes. And we want to know how many outfits we can make. We have red, blue, white, or black shirts, black, white, or tan shorts, and either white or black shoes. So what we do with the fundamental counting principle is we have one line for each event. So the first, we're calling it event or outcome, is the shirts. So this is for the shirts, this is for shorts, and this is for shoes. And we take the number of possible outcomes with that event. So we have 4 shirt colors, we have 3 short colors, and we have 2 shoe colors. And if we multiply this across, we get 12 times 2, 24 outfits in all. So for every part, the shirt, short, and shoes, you take the number of outcomes, the number of options, and you multiply across. So now that we know the fundamental counting principle, I'm going to associate our sample spaces to prove that the fundamental counting principle is true. So if we want to find the number of outcomes in rolling 2 number cubes, we have a number cube which the different outcomes are 1, 2, 3, 4, 5, and 6. If I roll a 1, I can get a 1 through 6 on the second roll, any of those numbers between. A 2, I can get anywhere from a 1 to 6 as well. If I get a 3, I can still roll a 1 through 6 on the next one, 1 through 6 on the next one, a 1 through 6 here, and a 1 through 6 here. So for each one of the number cubes, there are 6 branches. So we had 6 options initially, and each of those options has 6 branches. So our total outcomes, 6 times 6, which is 36. Now, according to the fundamental counting principle, this would be roll number 1. And here is roll number 2. So the first roll, there are 6 possibilities. The second roll, there are 6 possibilities for a total of, you guessed it, 36 possibilities. Great. Let's look at another one. So if we're looking at tossing a coin, And we're going to toss actually 3 coins this time instead of just 1. First we'll show our sample space, and then we'll demonstrate the fundamental counting principle. So, if I toss a coin, if I toss 3 coins, I could get all of them heads, or I can get heads, heads, tails, or I can get heads, 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 tails, heads, or heads, tails, tails. Or I can get tails, heads, heads, tails, heads, tails, 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 heads, or tails, tails, tails. So these are the different outcomes of rolling 3 coins. Of tossing 3 coins. So if I use the fundamental counting principle, this is coin 1, this is coin 2, this is coin 3. Each coin has 2 possible outcomes, heads or tails, and we multiply that across. 2 times 2 is 4, times 2 equals 8 outcomes. And did I get 8 outcomes in my sample space? 1, 2, 3, 4, 5, 6, 7, 8. I sure did. So look at that, the fundamental counting principle, and it works. These next 2 examples we will do without a sample space. Yay, we're going to save some time and some energy here. So if we can choose one of 3 processor speeds, one of 2 sizes of memory, and 4 sizes of hard drive. Okay, so what we're looking at here is we have our speeds, times our size of memory, times our hard drive. So we have 3 different speeds, 2 sizes of memory, and 4 hard drives. 3 times 2 is 6. 6 times 4 gives us 24. So we have 24 possible outcomes for number 4. All right, for number 5, we're choosing a 4, 6, or 8 cylinder engine. I'll change my color so you can differentiate there. Okay, so this is our engine. And a 2 or 4 wheel drive. That was messy. So our engine, we have 3 options, a 4, 6, or 8 cylinder, and our wheels, we have either a 2-wheel or 4-wheel drive, so that's 2, and 3 times 2 equals 6, so we have 6 options on the type of vehicle that we're getting. Now it's time for you to try. Go ahead and work out number 5, 6, and 7 on your own using the fundamental counting theory. And then when you're done, you can keep going and check your answers. Here is the key to the U-try. So now you want to go ahead and write your summary and rate yourself.